So far in this course, we have simplified the complex behaviour of objects and their motion by considering them to be particles. But now we want to introduce the concept of waves, and we'll introduce the basic properties of waves that emphasise the aspect of wave behaviour that's common to all waves. But first we need to ask the question, what are waves? Essentially, we can think about waves as vibrations going somewhere or propagating disturbances. We'll talk about this more in a moment, but let's think about all the waves we encounter on a regular basis. Water waves are the obvious one to think of, and they come to mind immediately when you start discussing waves, but there's also visible light waves, seismic waves in terms of earthquakes, sound waves, which we use to communicate, microwaves, shock waves, standing waves, etc. There's a lot of ways we interact with on a regular basis. In fact, 2 out of the 5 human senses are essentially wave detectors. That is, of course, the eye and the ear. So the physical properties of waves. When waves go through a medium, the atom or molecules in the medium are disturbed and oscillate, but there is no bulk movement of the material. This is an important point. So while a wave goes past, individual particles in the medium move, and in fact they undergo simple harmonic motion. So their oscillation can be described by the physics that we've talked about in the previous videos. Waves move energy and momentum. They propagate this disturbance, but they do not involve the bulk movement of the medium. Sound needs a medium to travel or propagate, but light is a special case and it doesn't require a medium. Therefore, in space, which is a vacuum and therefore has no medium, it's true that nobody can hear you scream, but they can see you wave. Let's talk more about the physical properties of waves and start to define some of the basic properties. One important aspect of waves is the wavelength. This is denoted by lambda. It is the point-to-point measurement of the length of the wave. Let's draw our now familiar sine wave, and I'll show you what I mean. So if we choose a point, the peak to peak, this is defined as the wavelength. Another important concept, of course, is the frequency, and we're quite familiar with that now, and that is how often a wave passes a given point. The velocity of a wave is the speed of the travelling wave. The amplitude, we're also familiar with that, is the height of the wave, and I can write that to the diagram here too as A. And with units, wavelength is in meters, frequency, hertz, velocity, meters per second, amplitude in meters. Now we can start to pull some relationships between these quantities, and one important one relates the speed of a wave to the wavelength and the frequency. The velocity is the product of the wavelength and frequency. Some important speeds are the speed of sound, and this is often quoted in air at 20 degrees C, i.e. room temperature, and this is 343 meters per second. And the speed of light, this is always the same, and remember, light requires no medium, it can travel through a vacuum, and it equals 3 by 10 to the power of 8 meters per second. Very fast.